mission here is to share meaningful content to help our customers be better at what they do day in and day out. So today we are fortunate to have one of our partners and one of the companies that we represent, Duquesne, Joe Ray, representing Duquesne, to talk about ultrasonic bonding for PPE. Obviously, the PPE world has exploded, and so has the need for bonding equipment. So what we're going to talk about, or what Joe's going to talk about, is some of the technologies. We'll talk some automation and talk about, just how does it work overall, the pleating and welding and everything that has to happen in order to make a mask stay together. I think, all of us at this point have probably had the mask where we go to try to put the ear loop over our ear and it pops off because they probably didn't use Duquesne equipment to weld those ear loops on. That's what I say. That's what I blame it on anyway. So anyway, with that, Joe, maybe tell us a little bit about you and your background and help us understand a little more about who you are in Duquesne, and then let's have some conversation.
Sure. Thanks, Russ. No, my name is Joe Ray. I've been at Duquesne since the 95, which seems like forever now. And I've been working in the non-woven market segment and packaging and food market segments for Duquesne since the 2000 timeframe. And, it's funny, Mark Iantoni, who's also on the call from Duquesne, we were chatting about this not too long ago, and we haven't really seen mask applications in about 15 to 20 years in the States, because that was like the last time people actually, tried to make some of these things here. And of course, now with the pandemic, everybody's been rushing to make masks, and we've had various waves of interest level come through. And the first has been for machine builders who are looking to produce machinery that involves ultrasonics to manufacture masks. And as of late, we've been getting a lot of inquiries from people who have bought machines from Asia, who have brought them into the country and now need to retrofit sonics that are reliable, that are made here in the States, to replace the foreign ultrasonic components. And that's been the second wave of it. So I think what I'd like to do is just kind of go through some of the different masks and the processes involved to make some of the masks. And if you could maybe advance the slide to the next one.
Sure. Before we advance, Joe,
Sure.
I remember a story about the beginnings of Duquesne and kind of how Duquesne came about. And if that was the Duquesne was the first to introduce the transponder, right? The transducer.
Well, Duquesne goes back to 1922, and back in the day, we were making battery-powered AM radios, and the company's kind of reinvented itself along the way. The name Duquesne came from the acronym of DuPage County and Kane County, and we're on the border, out in the western suburbs of Chicago. We're about an hour and a half west of Chicago, depending on the traffic flow. It's a small river town, St. Charles. And back in the day, that was a big agricultural community. It was also a recreational area for people from Chicago who wanted to go out to the country and hit the river in the summertime months. So back then we were making battery powered radios, and the company evolved over time. And we got involved with piezoelectric transducer technology to make acoustical pingers. And these acoustical pingers are used on the flight recorder box on an airplane in the unfortunate event that the plane lands in water and they need to recover the black box, which is actually orange, but that is a piezoelectric transducer technology that helps locate that device. Well, back in the late 60s, people were wondering, well, what else can we do with this technology? And some of the folks that were back at Duquesne back then were like, well, we understand that, people are using this same technology for cleaning things, and they're also using it to weld plastics. So Duquesne got its start in ultrasonic welding in the late 60s and early 70s. And along the way, we've patented and developed many new processes and equipment and features for the industry.
Very cool. Thanks for that.
Oh, no problem.
Quick history there. I thought it was interesting how it started with those piezoelectric, transponders essentially in airplanes, and then has continued to evolve over the course of time.
Sure. So this is a typical machine that's used for making surgical face masks. There's several stations involved in the process. There's the unwinding, pleating, bonding of the side seams and cross seam, and then there's the air loop station. If you want to click on that video link. So the first stations that were shown in the video were the side seaming, the pleating, and here they're showing the ultrasonic bonding of the air loops onto the mask blank. And then they're just trimming them and then accumulating. So there's usually multiple stations involved for the air loop welding because it's a slower process. If you want to go ahead and advance to the next slide, we'll kind of walk through the various steps. So basically, if you do an overhead view of what we just saw, this is a kind of a simplistic look, but it helps understand that the first station is side seaming, then there's a cross weld, and along with that stabilizes the pleats in position, and then you go to your air loops. If you do the next slide, we'll
Yeah, so talk to us about, you mentioned that when we were speaking about this yesterday, that this process here in the front end tends to be faster than this ear loop process.
Yeah. That the side seaming and the cross seaming is a continuous ultrasonic process, and can run at 60 to 80, 100 parts per minute, even faster in some cases. And the air loop bonding is a plunge process, which means it's intermittent. So typically you have to have more air loop stations to accommodate the output of the blanking stations.
Yeah.
So if you look at, here's a little cross-sectional view of that side seam, and you can see that roller. So here's our ultrasonic horn or sonotrode. Here is your sealing anvil. This is the process flow or the web direction. This is the cross seam, which is that weld. And these are the side seams, which are these welds. Does that make sense?
Sure does. So one would assume that the diameter is the length of the mask, the diameter.
Yes. One revolution of this rotary sealing tool is one mask, correct?
Got it. Okay, cool.
And then the station after this is a mechanical cutter that cuts it to length, right in between the two welds, because there's a leading edge and trailing edge. So if you were to imagine another mask stacked on top of this, you would cut right through that weld.
Got it.
Okay. So this is the blank station, and there's pleaters upstream and stuff like that. And then the next station is the air loop station. So you have two horns from underneath the mask, and you have two anvils that come down, pneumatically driven, and you bond the strings onto the mask blank. And there might be another station next to it to keep up with the process that's further up, that's upstream. So that's typically what you see in those machines. Okay.
Got it. Yeah, for sure. And so what's interesting, so if we talk about from an anvil perspective, for those that aren't familiar with ultrasonics, the anvil is just the backing that we bring down, and it does not move as the ultrasonics move into place and move at however many hertz per second, depending on the frequency.
Yeah, majority of the stuff that we've been supplying during this pandemic has been 20 kilohertz, and it's basically because the 20 kilohertz tooling gives you a wide variety of sizes to work with. Mm-hmm. The air loops could be done in 30 kilohertz if you're looking to conserve space and lower noise. There are some advantages to 30 kilohertz in this application as well for the air loop portion of it. But that's typically what we've been providing to our customer base at this point.
It looks like a big horn for such a small weld.
It is, and they're just trying to cover that distance. And most of these masks are about 4 inches across, or 3.5 inches across. So you need about 110 millimeter wide horn, so you can capture both points with the same horn and have two individual anvils from above to weld it. And squaring things up, leveling things, and making sure that they're flat and perpendicular to each other assures good welding.
Cool.
Okay, let's see, next slide. The other mask that we've been seeing is what we call a foldable or KN95 mask. I believe KN95 is the Asian equivalent to our N95. It's just that these are foldable masks. They're a little bit lower cost to produce. It's a higher efficiency of filtering. And this is a mask that is gaining in some popularity. It's very easy, simple to make. It doesn't require thermoforming like the formed masks, but it's a very common mask, and you see these all over now too. There's a little video clip showing how this mask is produced in automation, and then we'll break down the stations. So we're just accumulating material here, unwinding the various layers of the filter media. And this horn has a very wide pattern, and we'll go through this in a little more detail. And you can see it's welding that complete perimeter of this mask. There's a die cutting station here for a relief or a vent that's installed at a later time. They're doing a little pad printing here, just putting some identification on the mask. And in the next station is a string or air loop attachment. You can see the little scissors cutting in, and I guess they're just highlighting the pad printing portion here. But there they're welding the air loops. It's in the flat state. So you got the left side and the right side being welded. And once it gets past this station, it goes to a folding station where the mask is actually folded in half. So it's a symmetrical pattern. You can see it's going through the folder.
Looks like about a 2-second cycle time.
Yeah, sounds about right. I think these masks do anywhere from 30 to 50 a minute, depending how they got it set up. We have other technology that could speed this up. And here they're doing the final seam weld. It's about a 6-inch wide by 1-inch wide horn, and they're just welding that nose and bridge. Okay. And then,
that horn was a hog.
yeah, it's kind of a good sized tool. I believe they were using 15 kilohertz. Why they did that? There's that weld, that little angled weld. That's that final weld I was referring to.
Mm-hmm.
And then the next station is a rotary die cut. And then you have and they haul away the scrap, and then you have the finished mask blanks. So that's what that one's about. So let's break down those stations. We have, this is not exactly that drum, but first up is this large anvil, and we're welding out this pattern in that continuous process. Next step is the ear loop welding. Again, with the horn from underneath and the 2 welding anvils from above. The folding of the mask. The ultrasonic welding of that final seam, that's kind of that angular shape. The die cut and the scrap removal, and the mask is complete. Now, that is a automated process. And for something like that, Duquesne would typically supply 4 pieces of ultrasonic probe systems. So here's the IQ AIM systems. So you'd have you'd have 1 for the rotary mask blanking station. You'd have 2 probes for the ear loops, left and the right. And then the final weld for that final folded seam, which is another. So there'd be a total of 4 ultrasonic systems. And that's basically a generic look of what the power supplies look like and the typical ultrasonic stack assembly. Sure. So that's typically the component level that we supply, and we have various levels of control. And if a customer wants to do some on Ethernet IP or Profibus or Profinet, we can talk to them, and our equipment's fully capable of working with a lot of different PLCs and controls. So it's really, when we get to that point, I'm sure we have a solution for that integrator. Now, some customers we've been seeing want to produce N95s, but don't have a budget or don't have the time available to build a fully automated piece of machinery. So one way you can go about making a foldable N95 is to have some material die cut to shape. So you would have the filter media, the 3 or 4 layers cut together, right? In this shape. You would load it into your fixture, and then you would bring the ultrasonic horn down, a block style horn, and weld that periphery, okay? And all that detail out. The next step, you would weld your ear loops by hand. Maybe you can do that with a hand probe to keep it simple. And then in the last fixture, you would fold over the mask, locate it. It's got some locating details, a little clamp, and then you would put it on your ultrasonic press, and you would do that final weld. And then that would give you a folded, complete N95 mask. So,
that's been something that you all have.
Yeah, this is something that we've been helping some customers. We've gotten a lot of interest from Latin America, the Caribbean, developing countries where, maybe, a full-blown automated system is not in the budget, or the lead time is just prohibitive and they need to start making masks now. So this is another way of producing a foldable N95 style mask.
Got it.
The other application that's out there now is because the N95s are in such demand, some of our first responders are using these reusable respirators in these situations because of supply and demand. And what's good about this product is that it uses the mask is reusable. It uses much less filter media. There's a lot less waste. It may not be ideal for, comfort, but it's a very effective and protective device. It's very good at filtering out particulate. And here, they just replace those filter cartridges. And most of these are what we call the pre-filter. Typically, there's a cartridge filter underneath that has a lot more surface volume. And prior to that, they'll put a replaceable element that's the pre-filter that kind of gets out the bigger stuff. And
this is you probably don't, or you may know the answer to this question. I don't know, so I shouldn't ask a loaded question. But how long should we use this media? Like, how long will it? You use it for a day or 10 days? Like, I keep using the same mask. I mean, is there?
Well, they say that the surgical masks are single use only, and I'm guilty of wearing it multiple times. But generally after a while, they absorb a lot of moisture, and you'll notice on a warm day, it becomes very difficult to breathe through some of them. So you may have to replace it more often. I would probably change it once a day at the very least. On these, I really don't know the specifications that the manufacturers are advising people to change the frequency of the components inside. But, Duquesne did some ultrasonic servo welding technology. And it lends itself to cut and seal of these elements in one step. So in this little video here, I don't know how to change the volume, but you can just see we have a lab setup, and we're taking the multiple layers of filter media, and with the servo, we're able to weld and cut the media and the disc all in one operation.
Very cool.
Yeah, and that lends itself to automation quite nicely as well. So there's a lot of savings to be had doing it that way versus
Yeah, you should probably note that the more typical way of doing that, Joe, is the weld and then cutting through the weld with a separate station.
Yeah, and that was kind of like the old method of doing it, which is fine. Unfortunately, though, with automation, I mean, if you have to weld something, index it, and then cut it, there's potential registration issues.
Yeah,
and also it's another step in the process. So doing it ultrasonically in one step is a huge advantage for some of these applications.
Makes a ton of sense. Otherwise, the alignment, like you said, the alignment, you're gonna cut them in half, or not in half, but you'll miss the actual weld seam.
Yes. This was a simple application. It's bonding of straps to face shields, and completely dissimilar materials, but actually what we're doing, we're embedding one into the other. And this was done with a simple handheld system. So if, we've had customers say, hey, we want to make some face shields, we want to help out, what do we do? And, they don't want to use adhesives or get fasteners. So with ultrasonics, you could just use a hand probe and weld the strap to the shield. So it's a very simple application. It works quite well. And it's really, it's something that we've had some success and customers are asking for. The others, let me move the next slide. So, and this is something else. I know you guys are down in the Carolinas, but Freudenberg is partnered up with the Nonwovens Institute at North Carolina State, and it sounds like they're going to be working in Freudenberg. I don't know if you're familiar with them, but they're a huge nonwoven supplier of filter medias. I think they may be one of the largest, but they're out there. That's in North Carolina State, and they are working on some new mask developments, and I believe they're going to be working on mask machines. So it might be a touch point for you guys.
Yeah, actually,
Yeah, for sure.
it was on the news here. They've actually procured equipment and they're making masks using Freudenberg's nonwovens.
Yeah, it'd be interesting to see what ultrasonics they're using, because sonics is the preferred method. So it's something to maybe look into. But there's their website's quite handy. There's a link there. You might want to reach out to these folks. We have a whole host of other technologies that we do for nonwovens. I just covered our traditional. If we wanted to do another segment another time on rotary horn technology, that's a whole other topic that's quite large, but it definitely has advantages in bonding nonwovens at higher rates and higher throughputs. Duquesne also recently applied for a patent on a mask design. I don't know if you're aware of that.
No.
Yeah, we purchased a company in Wisconsin a few years ago called Horizon, and now it's part of the Duquesne company, and they had proprietary rotary horn technology. So when we bought Horizon, we purchased. We also received all their intellectual property, and one of the things that they had was something called elastic entrapment, and basically it's getting these lycra strands trapped between two layers of nonwoven, and you're forming an elastic band, so to speak. So one of the fellows up there thought about this and thought, hey, Matt, we might have a unique way of producing a mask at a very high speed that potentially could be a game changer in the industry. And we filed for a provisional patent. I just need. Okay. So this kind of shows the production of a mask. This is a cross seal that happens, but in essence, this is what it looks like. It's kind of like a scarf.
Oh wow! But unlike the T-shirt material that people are wearing around their heads these days, this is actual filter media, huh?
Correct. And what's important to note is that the elastic will keep everything snug around over the ears, around the hair, under the neck. It accommodates folks with beards. It has a lot of surface area, which makes it a lot more comfortable for the users. And we have a lot of claims on this. And again, there's a provisional patent that's been applied for. You can see the linear inches of filtration area versus the other. And it works really, really well. And I believe they've done some testing. We've done a couple of different variants of it. And again, it's something that's pretty slick. And we're just hoping to find a partner with it. So, and again, it'll be on a roll, and then you'll be able to pull it off and then tear off the piece that you need, the mask. So you can have this inside of it'll be like dispensing a wipe, so to speak.
Then how do you wrap it? Does it stick to itself when you wrap it around your head, or?
Well, you got elastic. It basically just imagine like one of
Oh,
those.
because yeah, it's
Yeah.
it's circular, so that's why
Yeah.
it was. Okay.
Yep. So yeah. So yeah, that's one of the things that we're excited about. We have some proprietary, like I said, and patented technology used to manufacture that. And like I said, if you'd like to have the guys from Horizon on an episode on one of your your meetings, that'd be fine.
Appreciate that offer. We'll take you up on it, most likely, for sure. So, all right. Anything else? Is there anything else to share? Does any of the team have questions for Joe?
Joe, this is Chris. I've come across a couple of opportunities and forwarded one to you. So we'll get together maybe offline and explore that. I'll also get in touch with this team at NC State as well. I know they are engaged with many manufacturers in the area, so it could be good for us to partner.
Absolutely. Yeah. The Carolinas are a big area for nonwovens, for sure. So there's a lot of high tech technical fabrics and textiles that occur out of the Carolinas and the Southeast.
All right, very good. Well, we'll go ahead and wrap it up. I've got a chainsaw that's seems to be right outside my window here. They always seem like they're right next to you as you're concluding one of these or in the process of having a Zoom call. But Joe, really appreciate you jumping on today. Mark, thank you for helping to coordinate the conversation with Joe about PPE and bonding and what the latest is. And it's pretty cool to see how the masks that we are utilizing every single day are being manufactured and using the technologies that we sell. Makes it even better. So we appreciate that. And as always, as we go to end these calls, we appreciate all of our customers. And without you, we don't exist. So if you need to connect with us, of course, Adam Hooper, Chris Mullins, Mike Dorsey, and myself, Russ Sorrells, we are ready to serve you however we can. Any questions at all, please just leave them in the comments below or email us, and we will get you some answers. So again, thank you, Joe. Thank you, Mark.
Thanks, Russ. Thanks, guys.
Appreciate it, guys. Take care. Enjoy the day.
Have an awesome day.
Thanks, Joe. Thanks, Mark.
Okay, bye-bye.